Okay, the class just answered this question, and we had the correct answer, which is excellent. And let's look and see why that is. We have 40, comma 000, or 500. Sorry. 00. All right. Now we have the rule that trailing zeros count sometimes. And what makes them count? Decimals. Okay, so there's no decimals in this number, so these guys right here are trailing zeros, and they do not count, and that's why we have 3 sig figs. Okay. Okay, the class has just answered this question, and it looks like people are in pretty good shape here. Most people, 77%, are getting it right. So for the others, let's go ahead and look at B a little more closely. 0.0. And why would that be 111.0? Why would that guy be 4 sig figs? Well, here we have a trailing 0, and that trailing 0 is going to count because of the decimal that's right here. So we have 1, 2, 3, 4 sig figs. Any questions on that? You need to look at your little sig fig thing, counting sig figs the easy way. I think I had you put that in your miscellaneous section. And if you have that in your miscellaneous section, you can pull that, or you can look at it and pick it up in my website under standard stuff, class forms and charts. And you'll see that in one of those sections there. Okay, for this question, we had 65% of the students were correct, and letter D should be the prefix for the quantity point. No, yeah, micro. Yes, yeah, letter D, micro. I was looking at kilo. So we're good there. Now I'd like to take you over and take a look at the sheet that you all have that would have been a big help for you. And if you don't know this stuff, you might want to put these prefixes on your help sheet. So if you have this little sheet, it would make it extremely easy for you to get this answer correct. And because on the question itself, you're looking at 5 zeros, that's 10 to the minus 6th. So 0.00000, yeah, 5 zeros and then a 1. That indicates that we are using this guy right here. Okay, so micro is our answer, and you know, when you're doing conversions, also I've got a lot of examples here that show you, 3 of them, that show you how to do those conversions using the fractions or the grids, as they look like in this one, to go ahead and do those conversions. And it's all right there. So this particular page can be found as you look down here under tutorials, and you look for tutorials on my website under the heading of Learning Center, and then you would look for chapter 2, and you would find a link to be able to print this particular page. Okay, the class has just answered letter A, 76% getting it correct. And which of the following is in volumes is the smallest? So they're all in liters. Notice that? All of these are in liters. So all we do is look to the left, find the prefix that is the smallest, and we got a milliliter there, a deci. Okay, milli and deci. Deci is 0.01, and or deci. Is that right?
No.
0.1. Oh yeah. That couldn't be right because centi is 0.01. So deci is that guy. Milli is 2 zeros and a 1, And liter, of course, is 1. And then micro is 1, 2, 3, 4, 5 zeros and a 1. And that makes it pretty clear why this guy would be the correct answer. Oh yeah, a microliter, you can actually measure it. It can be measured. Oh yes. Accurately. Yes. And basically that kind of a tool, instead of having a graduated cylinder that you pour things into, it goes through a tiny tube. And you can start moving the thing. You fill the tube up, and from the end to a certain point, let's say you wanted 5 microliters, 5 microliters might be from here to here. And so what you do is you start pushing the thing up until it comes up to the right number, and you're there, and you're right on. Yes?
How much would something like that cost?
Oh, I don't know, a tool like that, probably $100 or $200. Relatively inexpensive.
What?
Yeah. Okay, let's see how you do on this guy. Don't do that. The class has just answered the question, and the correct answer was D, and D seems to be in the minority, which is a problem. So let's look and see how this works.
You said which one is the largest?
I'm sorry?
This is the largest. D is the smallest.
E is the smallest. Whoa! Wow. Okay. Well, we got something to correct, don't we? Let's look at that again.
No, everyone got E.
D. Yeah, that's the smallest, and they wanted the largest. Okay, so that was definitely wrong. And as you look over here, this is the other way those things could be rendered, and this is the third way they could be rendered. Yes?
You marked it wrong.
Yeah.
Of course it marked it wrong.
But it was right.
Okay, yeah, B is the correct answer. I've got to fix that. I just told you that, didn't I? Okay, so this is how these prefixes go, and in the bigger thing, it shows it that way. Okay, on this problem, I didn't have time to have a class go through this, but we can look and see that the correct answer in this particular case is A. At least I hope it's correct. We're going to check that in just a minute. But we got 7,896 mils. That would be like our given. So we're going to put that over 1. And to do this conversion, we have to have something that takes us from milliliters to meters, right? Here's how you do that. Milliliters, excuse me, I'm going to take this prefix and I'm going to put the liters here, and I am going to do this to show you that milli is 1 over 1,000. That's how you create your conversion. Now we know that 1 milliliter is equal to 1/1000th of a liter. Now if we multiply both sides by 1,000, we know that, whoops, not 2. We know that 1,000 mils is equal to 1 liter. Okay, and that's where we're going to get our conversion factor to pull this guy in down here with its number. 1,000. Please sit down till I'm done. And the top side would then be this, and we put our 1 liter up here. And that's how we run our conversion. Now, dividing by 1,000 moves the decimal from here to 1, 2, 3 places, 7.896. And that's how you do that kind of conversion. Okay, this is the last problem. Why don't you try working this on your own? And you do that by stopping the video and taking a look at how you would solve it. And then I'll go ahead and do the solution for you as well. Okay? Hopefully you have worked it on your own. And let's do the given and find here. This is how I always do things. Given and find. So given, we've got 80.0 grams. I'm copying from here. And this is ether. And now the next thing you've been given is the density, which is 0.70 grams per mil. And that would also be for ether. And what are we asked to find? The density of ether is this. What is the volume? Okay, so the volume is what we're supposed to find. Anytime we're given grams, we are always going to be asked to find mils. So that's the kind of problem it is. It's going to require fractions. And we are going to start our fractions with the given over 1. So we start with the given over 1. And that is going to be the 80 grams of ether. It's a given quantity, 80.0. And that's over 1. And the substance is ether. So we want to make that in there as well. Now, the next fraction, we know that the grams is going to have to go on the bottom. And what does that mean? So let's go over and do a little sidebar. We've got to have our density in a little bit different manner than it shows right now. So I'm going to write the grams that is equal to, and I'm going to write this in such a way that I can move these guys separately. So we've got the 0.70, and that's grams. And I'm going to do this in such a way that I can separate things, and you'll be able to see how this works when I actually get down to doing it. Now, the mils is on the other side, so it's 1 mil. And now you see these guys can be separated, and I'm going to show you why that's so nice in just 1 second. So, since grams is over here on the left, right here in our density equality, and we're going to be using this guy on the bottom. So, what I would normally do, instead of moving just the number, I want to always move the number and the unit, and so I group them together and bring them on down here. Now I already have grams there, so I'm going to put my grams back in the density equality. But the 0.070 has to be on the bottom. And now, just like for the bottom, the 1 always has to go with the mils. And so we put that guy there. So the next thing we want to do is cancel our units of measure, the grams, and now we want to do the multiply across the top and multiply across the bottom. Okay, since there's only one number besides the mils, the 80.0, we just multiply across the top and we get 80.0. On the bottom, we multiply across the bottom and we get the 0.70. And the bottom has no unit of measure because, as you can see, the grams here and the grams here have been canceled out. And now my final number that I'm going to come up with, I guess this may not be my final number, but we're going to divide the 80 by 0.70. And the number that comes up on my calculator is going to be 285, I'm sorry. Let's get this right. 285 and 7143. I'm writing all these numbers out to point out to you that calculators don't have any idea about sig figs. They're totally clueless. So what you want to do is always be able to know for yourself how many sig figs you have in any number. So let's go do that next. The 80.0, you're going to have 3 sig figs. The reason for that is trailing zeros count sometimes, And the sometimes is determined by whether or not there is a decimal in the number, anywhere in the number. So the 80.0, the 8, the 0, and the decimal 0 all count because they're trailing zeros. Now, on the bottom, the only thing that we have is 0.70, and to count the sig figs here, this trailing 0 right here will count. This 0 won't, because leading zeros never count. So I have 2 sig figs for this guy. So 2 sig figs on my other number, that limits my accuracy, and I go and look at the number, and I move the arrow here, 1, 2, and that's all the sig figs I get. So I'm going to have to make a line to the right of the second number. And now I look over here at this 4, and I see that that's less than 5. So I can rewrite this number, but I must make it the same size number. Even though it doesn't have the 4.2857143, I've got to rewrite it as just 11 with the 0, or 110. And let's write that just a little nicer, 110. And I would put no decimal in here because we only have 2 sig figs. So trailing zeros count sometimes. When do they count? They count when you have a decimal. So with no decimal there, that still is 2 sig figs, even though there's 3 numbers. And so 110 will be our final answer, and the unit of measure, which comes from here, okay, there's our mils. We're going to carry that down, and it will be 110 mils, and that is what we were supposed to find when we wrote up our original problem here. You see there that you have the defined as this guy. So that's how this one is solved, and that's why the answer is what it is. Letter B, because this can be converted to, let's go ahead and convert it. Letter B is 1.1 times 10 squared. The E that you see here, this little E, I can use this to point to. See this little E right here? That means 10, and 2 means the power of the 10. So that's 10 squared. Well, look what happens down here when I'm looking, there we go, at this number on the bottom. Let's move him up just a little so I have room to write. And I'm going to write that that number that was up there, 11 or 1.1 times 10 times e to the 2. 1.1 times e to the 2, and that is exactly what I had up above, because e to the 2 means 10 squared. That's it.